that basically when you are adding an element, hashcode algorithm will check the hashing algorithm will check the hashcode and equals method. Based on that, it will take the decision whether to add the element into the collection or not. So hope this is clear. So let's understand one more concept called collision. What is collision? So you must be hearing this in the interviews or any other while you're studying your theory or attending the class, right? So let's understand what is collision here. Collision is that basically once the hash map generates the hash code using the hashing algorithms, if the hash code is equals to another object, in that case, basically what happens is that the hash map has to store this object in the same bucket as the previous one. Okay, so while storing that, basically it's a hash code collision. That is the concept here. Basically, once the hash code is equal to another hash code, basically the collision occurs. So the hash map will utilize the linked list to store the objects. Okay, let's see that in example how we can generate the collision here. So here we have John 21. Ideally, these two objects are different, right? They are not equals. If we use the equals method, here we are getting equals is true because we are overriding it, right? In case we are not overriding it, it gives the actual value, right? In that case, basically what happens? Let's try to check this. So it is false. The two objects are not or false, but the hash code is same. So this is the case where the collision occurs. So if the collision occurs, the object is stored in the same bucket as the previous one. So these two objects are stored in the same bucket. Now that you can see the size as 2. So this is the collision in hash map. Hope you understand the concept here. To summarize, basically let's understand that hash map generates hash code using the hashing algorithms. And why it is generating the hashing algorithm? Hashing algorithm is similar to indexing in databases. Okay, it allows us to retrieve the data elements very fast. Due to for the performance reasons, it generates the hash code and it stores the data value key and values based on the hash code that is being generated, so that it can retrieve the elements fast based on the hash code. So let's understand the time complexity that is being used here. So to check the time complexity, let's go here. So the time complexity in any algorithm is based on these scenarios. Okay, it can be constant time, log time, linear, log linear, quadratic, cubic, and exponential. So it can be anything. O1 or the constant is the lowest. So if the algorithm is giving you the constant time performance, then it is excellent algorithm. Okay, if it is goes gradually, so it's a degraded algorithm where it is very much time consuming. So for hash map, basically it is O1 for retrieval. Let's see that basically for space, right? To extend the space when the resizing happens, basically it's ON, which is okay but not very poor. In search it's O1 very good, in insert it's O1 very good, and it's delete O1 very good. Due to that reason, it's using the hashing algorithms here. So like arrays, hash tables provide constant time. This is called the constant time O1, which we have looked earlier. So regardless the number of items, it remains the same. And hash tables are also used to speed up the string searching in many implementations. So since it's a constant time and gives very good performance, it's used in data compressions and searching on the data. Okay, hash tables are often used to implement associated arrays, sets, and cache. All right. So that's the theory of hashing, hash code, collisions, etc. If you have anything, just comment me. And if you have not subscribed, please help to subscribe so that it will help me to provide more videos. Thank you for watching.